When it comes to naming and drawing alcohols and ethers, it is easy to lose some mark from small details, not from a lack of knowledge. I have marked thousands of exam papers at both national and international levels, and I know exactly what examiners are looking for. So in this video, I want to share small but crucial tips that help you avoid unnecessary mistakes so you can succeed step by step. If you want to fully understand alcohols and ethers, you are in the right place. And my goal is simple. If this lesson helps you even a little, then it's done its job. So let's begin. Looking at these two structures, one gets penalty, but one gets a full mark. Can you spot the difference? Yes, it comes down to the precise position of the OH group. It is important to draw oxygen atom that's directly off the carbon atom. If the line which represents the covalent bond is drawn somewhere in between or towards the hydrogen, it is going to be a penalty. Just like English literature, it matters where you put apostrophe before or after. So let's be mindful of how you position the OH group. Here are some general informations of alcohols. It must contain OH group, sometimes referred as a hydroxyl group if there are multiple groups present in the compound. General formula goes CnH2n plus 2 with one oxygen if there's one alcohol group, and this shows there are maximum number of hydrogens corresponding to the carbon. And naming ends with anol, not ol. This is what we're going to look for in the next slide. And alcohol will have many uses, including disinfectant, just like hand sanitizers, or solvents for perfumes. I'll go through a few different structures of alcohol that involves 4 carbons, and by putting the hydroxyl group here and filling up with hydrogens, and you'll have 10 hydrogens with 1 oxygen. That matches the general formula. And having this 4 carbon in the main chain, we have a prefix with bute. It is written as but it reads as bute. And having this alcohol group, a lot of students will put ol as a suffix, but it reads as butol. Doesn't sound right, does it? So it's actually read as butanol. It's an anol suffix. And numbering the carbon from the side that's closest to the OH group, here's your number 1, 2, 3, 4, which shows the position of the OH group coming off the first carbon, so it is called butan-1-ol. The second structure still has 4 carbons in the main backbone, but I'll be shifting the OH group 2 slightly to the right and having those hydrogens filled in, and it'll have 10 hydrogens altogether, but it's important to start counting from the side that's closest to the OH group, which is to the right-hand side. So we'll be numbering the carbon backbone chain as 1, 2, 3, 4 like this. And the OH comes from the second carbon with a prefix of bute. Remember, it's an anol, not butol. So butan-2-ol will be the systematic name for this. Let's add a little twist in the next structure. Instead of having 4 carbons in the main chain, we can shorten the main chain by making one of the carbon as a side chain. An OH group can be positioned here with 10 hydrogens in the structure. And counting from the side that's closer to the OH group, starting with 1, 2, 3, which only shows 3 carbon in the main backbone. And having the OH group coming off the first carbon, the backbone will have a name called propan-1-ol. But at the front, we need to address this side chain coming off the second carbon, and having 1 carbon as a side chain, we use the prefix meth, and YL represent the side chain coming off the second, so it's called 2-methyl-propan-1-ol. And here is another exam tip here. If you get a question to draw the Lewis structure, you must show non-bonding pairs on the oxygen. Other atoms don't have the non-bonding pairs because all carbons and hydrogens, electrons are used in bonding. And also it's important to show a covalent bond between oxygen and hydrogen atom, and this shows the complete Lewis structure. Let's go backwards by starting with the name to draw the structure. It is important to separate the name into the main chain and the side chain. So drawing the propane 2-ol, we have 3 carbons, and on the second carbon, there's an OH group. Then on the second carbon, there's a methyl group. Remember, it's 1 carbon hanging off as a side chain. So we're going to address in the middle of the chain. In this case, since propane 2-ol has only 3 carbons, it doesn't matter whether you start from left to right or right to left because both OH and the methyl group is right in the middle and filling up with hydrogens, and that completes the structure. So when you can recognize and name the structure, it makes it much easier to draw one yourself. Time to advance. Let's have more carbons. We have 1, 2, 3, 4, 5, 6, 7, 8 carbons in the main chain, starting with a prefix oct. And I'm going to introduce OH group here, but to make it challenging, I'll put another methyl group. And remember, because this belongs to an alcohol functional group, it is important to prioritize the OH group and start counting from the side that's closer to the OH group. So it's not okay to start from the other chain where methyl group is closer. This belongs to an alcohol. And OH coming off from the third carbon, the main chain will be called octane 3-ol. And keep continuing to count, and the methyl group is hanging off the 7th carbon, so that concludes the name called 7-methyl octane 3-ol. Sounds long, but once you know how it works, this will be the most logical way to name the structure. Speaking of alcohols, we must talk about the alcoholic beverages. To chemists, these are just different flavored ethanol solutions at various concentrations. Human body can only tolerate ethanol because this is the only naturally occurring alcohol produced by our Mother Nature through the fermentation process. Don't get me wrong, because ethanol solution at much higher concentration is very toxic too. When you think about the hand sanitizer, which contains 70% or more ethanol, because ethanol has a very strong disinfectant property, but would you necessarily call it an alcoholic beverage and drink it? I wouldn't. All other alcohols apart from ethanol has a very high toxicity. So for example, about 3 grams of methanol can permanently damage the optic nerve, so you can put yourself at risk of losing your eyesight and eventually go blind. Let's focus on 4 most common consumable ethanol solutions, starting with beer containing 5 to 6% of ethanol, wine 12 to 15, soju, which is the most popular Korean drinks that you see in K-drama all the time. In fact, it actually started off as a 20.1% in late 1960s, but people found too much hangover and couldn't turn up to work the next day. So the company decided to lower the concentration slowly, gradually, and it came down to about 15.5% these days. And the last one is the strongest. Technically, we should say it's a high concentrated alcohol, ethanol, such as vodka or tequila, whiskey containing 40% or sometimes above. But have you ever wondered about different size glasses that they use for different types of alcohols? This is to keep the amount of the ethanol reasonably constant. Using N equals CV, when the concentration increases, the volume has to decrease to keep the amount of mole almost constant. Isn't this interesting? Now you can name all the alcohols, but it must be followed by how to classify each alcohol as primary, secondary, or tertiary, because different alcohols, whether it's a primary, secondary, or tertiary, reacts in a different way. So first of all, you need to identify the carbon that has the OH groups. Obviously, this is an alcohol. Second, we have to look for how many other carbon atoms that this particular carbon is bonded to. So the structure on the left has only one other carbon bonded to the carbon with the OH group, the hydroxyl group. So we say it's a primary alcohol. The second structure, it has 2 neighboring carbons left and the right. So it is bonded to 2 other carbons. So make sure you word this right in your assessment. You have to address this as a carbon atom with the OH group is directly bonded to 2 other carbon atoms. So the last structure, you guessed it, it must have 3 carbons, so it must be a tertiary structure. It's your turn. Feel free to pause the video and try to name the structure yourself. If you have this, well done. There are 2 methyl groups, so we need to address this as a dimethyl representing 2 of those. And both are coming off the second carbon of the main chain. So we've got to do 2, 2 dimethyl pentane 1-ol. Try to have a dash between the numerical value and the alphabetical value to gain the full mark. And last thing, would you consider this a primary, secondary, or tertiary alcohol? This is just another shorthand to write primary, secondary, and tertiary, by the way. And now you've got it. C with OH is only bonded to another carbon because those branches are coming off from the main carbon too. So this must be a primary structure. Okay, we are advancing a little bit more. What happens if we have more than one OH group? So we'll have OH here and another one here and adding hydrogens. And having 6 carbons in the main chain, we will start with a prefix with hex. Then addressing the position of the OH group, and make sure you start counting from the side that's closer to the OH group. So we're going from left to right, and we can see the OH group actually 2 of the OH groups are coming off from second and third, and having 2 alcohols. This is hexane 2,3 diol. And now you can see where di came from. For those who are taking biology, you might have seen this triglyceride structure made with glycerol and 3 other fatty acids. So let's just have a look at the structure of glycerol that is used to make the triglyceride. Having 3 carbons in the main backbone, I've deliberately left it vertically, but feel free to change this into horizontal form. It has 1, 2, 3 carbons in the main chain and 3 hydroxyl group, as you see, 1 on each carbon. So this is called propan 1, 2, 3 triol to represent 3 hydroxyl group, commonly known as glycerol. This is interesting because the hydroxyl group, the carbon, the number 2 in the chain, this is actually a secondary alcohol having 2 other carbons, carbon 1 and carbon 3 directly bonded to it. Whereas the hydroxyl group, the carbon on number 1 and number 3, they are primary alcohols. So it's a combination of primary and secondary alcohols in a single structure. You might be surprised to see more alcohol-containing compounds around everyday life. This is called cholesterol, and you guessed it, finishing with the suffix -ol, it must contain the hydroxyl group right here. And cholesterol will have such a long systematic name if you use methyl, ethyl conventions. So cholesterol is just a short name for everybody to use it easily. Just like this longest name in the Guinness record that I pulled out from Google search, and nobody would call this person with the full name. I wonder if even this person can spell his own surname though. Second structure, you might be familiar with a vitamin A. Its actual name is retinol, and again, it will contain the hydroxyl group. And both are non-polar structures because both have such a long carbon chain called alkyl chain, and any alcohols or hydroxyl group that contains more than 4 carbon has lower polarity, making them non-polar overall, so they are insoluble in water and they can dissolve in any other non-polar solvents. So we say it's fat soluble. You have mastered alcohol and time to move on to ether. This group is always found in the middle of the chain, and ether is a functional isomer to the alcohol, so the general formula is exactly the same as alcohol. The one thing that's most important when it comes to naming the ether is to look for the longest alkane chain. So ether doesn't have to take part in the longest main chain. It'll be viewed as a side chain. Let's get it started. I'm going to start with 4 carbons, accompanied by oxygen in the middle of the chain, followed by more chains. Here in the blue highlight, it shows the ether functional group, so make sure you circle both carbons on either side to gain full mark. Then let's add hydrogens to it to avoid more penalties. Remember to look for the longest chain of alkane. So you got to look at the left and right and see which one has more carbons. And surely we have 4 carbons on the left, which is longer. So this part will be addressed as butane. And the other part, the ether group, will be seen as a side chain with 2 carbons. So this is called ethoxy. Eth brings the 2 carbons, and oxygen is followed by oxy. But we don't call this butane ethoxy. We're just going to change that ethoxy as a side chain, followed by the butane, so it is named ethoxybutane. No need to have numbers or dashes because there is no numerical value involved in this. For this one, I would like to introduce skeletal formula. So once you get it, this is easy to work. So to avoid any penalties, represent carbon as dots. So we got 4 carbons on the left, followed by oxygen, 2 carbons on the right, and all you do is to join them with the lines together. And this avoids drawing extra lines or one less lines, which is very common. Okay, let's get it done with. There's your ether, and I'm introducing more carbons to the structure. And having hydrogens here, and that'll add up to 14 hydrogens since we have 6 carbons. It's 2n plus 2 for the number of hydrogens, followed by 1 oxygen, exactly the same general formula as alcohol. And we have 5 carbons in the main alkane chain, so this one will be called pentane. And having ether as a side chain with 1 carbon, it is going to be called methoxypentane. And if you get a question about Lewis diagram, make sure you bring the lone pairs on the oxygen. This one will help you to deduce the bond angles, and also it'll help you with a hybridization if you take IB higher level or AP in the Cambridge. So skeletal formula is the same way, 1 carbon as dot, followed by oxygen and 5 other carbons as dots. So join them with a single line. And actually those lines have angles because they represent the tetrahedral nature of all the other carbons. And condensed formula, just reading from left to right without any dashes, representing covalent bond. So CH3O, and you have a repetition of CH2 many times, so you can even condense it further using brackets. Pause the video and challenge yourself, because this structure, more than 90% of students will make mistake on it. So there's my first hint. Look for the longest alkane chain by ignoring the ether. There's your longest chain having 1, 2, 3, 4, 5 carbons, which will be a pentane. And there's an ether group with 1 carbon. On the 3rd carbon of the main chain. Since it's in the middle of the chain, it doesn't really matter which way you count. So I'm going to stick with the red numbering. There's a 3-methoxy, and don't forget the side chain, that is a methyl group. So this will be 3-methyl. And we have to go by the alphabetical order. Both have meth, but one has oxygen, one has Y. So methoxy comes first because we're prioritizing the alphabetical order, and having 3-methyl as a second side chain. And don't forget to add the dash between the number and the numerical and the alphabet. So if you could name it, congratulations, you can do everything yourself. These shows 3 monosaccharide structures, which is made up of C6, H12, and O6. Whenever you get a question to identify the ether functional group, make sure you circle both carbons, 1 at each side from the oxygen. Same goes with the fructose, same goes with the galactose. And when you combine two monosaccharides together, it forms a disaccharide. And examples of them are sucrose, maltose, and lactose. And from each monomer, they have ether groups, but the linkage between two monomers, and biologists would know this as a glycosidic linkage, is also ether. If this video has helped you clarifying IUPAC naming of alcohols and ethers, take a moment to practice and apply this method yourself. That's where the real confidence comes from. And I'll continue sharing clear exam-focused strategy to help you. Thank you for learning with me, and I'll see you in the next lesson.